Now, separable equations are actually especially nice to work with because they can be solved in two logical steps: separate, then integrate. Let's take a look at an example, and let's try solving the initial value problem. dy dx equals 6y squared x, subject to the initial condition that y of 1 has to equal 1 over 25. This is a separable equation because I can write all of my y's on one side and all of my x's on the other. If I divide by y squared on both sides and multiply by dx over to the other side, I can rewrite my differential equation as dy over y squared equals 6x dx. And do you notice both sides of this equation almost look like an integrand? So we just integrate both sides of the equation. Over here, I get negative y to the negative 1. And on the right side, I get x squared over 2 times 6 is 3x squared. Now, I've left a little bit of space here because this is the first time in our course that we're going to have to start dealing with our constants of integration. Do you notice I get a constant of integration over here and over here? And one very tricky thing about reading differential equations is that people get very loose with the constants of integration. Do you notice if I move this c1 over here, and now I've got this c2 minus c1, we can almost think about this whole value right here as just being a single constant of integration. And so we could write negative y to the negative 1 equals 3x squared plus, just call it c. And most of the time when you're reading these things, authors will jump from here straight down to here. Right? They just assume that you understand we're absorbing each individual constant of integration into one big monster constant here at the end. We're almost done now. Last thing we need to do is isolate y by dividing over the negative 1 and then flipping both sides. This tells us that y of x is equal to negative 1 over 3x squared plus c. Now, we're almost done. That solves this equation, but it doesn't solve the initial value problem because I haven't applied my initial condition yet. If I look at y of 1, according to my form, I get negative 1 over 3 plus c. But my initial value tells me that that should equal 1 over 25. This information altogether, if I just look at this piece, tells me that negative 3 plus c should equal 25. So that means that c should equal negative 28. Altogether now, y of x, now that I know what c is negative 1 over 3x squared minus 28.